let's consider the vectors I, j, and k, where I equals a vector 1, 0, 0, j is 0, 1, 0, and k is 0, 0, 1, which are vectors of length 1, which you can easily verify if you take the magnitude of I. That's going to be 1 squared, square root of 1 squared plus 0 squared plus 0 squared, which is simply 1. It's the same for all of these. And these are in the direction, positive directions of the x, y, and z axes. So let's go ahead and just draw these real quick so you can see what I'm talking about here. See, that's going to be the x-axis. So over here is positive z. This is positive x. This is positive y. So if this is 1 and this is 1 in the y direction, this is 1 in the z direction, then what we have is I is right here. That's vector I. Vector j is right there. That's j. And k is here. So these are all of length 1, and because of these coordinates, I, j, and k correspond with the x, y, and z axes, like I said, for a length of 1. Then vector A in 3 space can be written as, I'm jumping to 3 space now. This can be written as A1 times 1, 0, 0. Well, I'm sorry, I said I'm jumping to 3 space. I've been in 3 space. I'm going to move this up here. I need a little bit more room to write. So the vector A, which equals A1, A2, A3, can then be written as, I'm going to write this as A1, 0, 0 plus 0, A2, 0 plus 0, 0, A3. So just by adding these components, so I take all 3 of these vectors. If I add the components, I will get vector A back, just as written here. But this I can rewrite as simply A1 times vector 1, 0, 0 plus A2 times vector 0, 1, 0 plus A3 times vector 0, 0, 1. Now the significance in that is that simply I can write vector A as simply being A1 times vector I plus A2 times vector j plus A3 times vector k. Now, what this means is that any vector, it doesn't matter what A1, A2, and A3 are, or even if I'm in 2 space, any vector can be written in terms of what's known as the standard basis vectors. I, j, and k are known as the standard basis vectors. So I can take this vector here, just call it vector v, and v equals 3, negative 1, 4, and I can write this as being equal to 3i minus 1, which is just simply minus j, plus 4k. Now, the reason that we want to do this is because sometimes writing this vector in terms of the standard basis vectors, it gives us some algebraic properties to work with that make it much easier in terms of general representation of vectors. It's not necessarily something you always want to do, but it is very common because it is a nice, neat, and sometimes an easier way to help work with vectors. And this idea of using these standard basis vectors applies to other dimensions as well. We're not simply stuck with doing this in R3. We can do this in any dimension that we need to work with.